Hello student, let's see the preparation of alkenes from the alkyne student. How can you prepare the alkene student? There are the two ways are there student. We need to do the partial reduction student. Okay, from alkynes to get alkenes, we need the partial reduction. If you do complete reduction with the strong reducing agent student, it directly convert into the alkane student. So dear student, what we are supposed to do, we have to take the pelletized barium sulfate, or student what we have to take sodium in liquid ammonia. Here you see student, the alkynes on partial reduction with the calculated amount of the dihydrogen in presence of the pelletized charcoal student partially deactivated within the poisonous like sulfur compounds or the quinoline give the alkene student. So students, what we are taking here, kindly see here the alkynes on the partial reduction with the calculated amount of the dihydrogen. We have to take the calculated amount of dihydrogen in the presence of pelletized charcoal student partially deactivated with the poisons like the sulfur compound student. That compound is what student? You can take the quinoline. So it will give the alkene student. Dear student, here you see this is the pelletized charcoal is there student, and in presence of what you are using QUONILINE. This is quinoline dear student, and this is the what alkyne student and hydrogen. So what you are going to get student, you are going to get the cis alkene, right? This is the cis alkene because similar group are same side. Dear students, you come back to this side. Suppose I am having CH3 student, this is the CH, and not the CH here, we have to take the alkyne dear student. So here these are their student, this is, and there is CH3. Now what we are taking is student H2, and that we have to take the PDC student in presence of quinoline. So student, the both the hydrogen is going to attach from the bottom student. So what the compound, this is the CH3, this is the double bond, here is the CH3, and this is the hydrogen because the hydrogen is calculated amount. So this is the cis butene student, cis butene. So this is what our required one. Now student, let us see the second part of the question. Partially deactivated pelletized charcoal is known as Lindelar catalyst student. Now the second case you see, alkene thus obtained are having the cis geometry. Okay. However, alkynes on reduction with the sodium in liquid ammonia from the trans alkene. Now student, see the same one, you are taking the liquid ammonia student, sodium in liquid ammonia, and this is the alkyne with the presence of hydrogen. One hydrogen will go from the top, another from the bottom. So here it is C forming student, this is what it is forming the trans alkene dear student. This is the trans. Now here you see, let us see the CH3, this is the C, this is the triple bond C, this is the CH2 student, that again we are taking H2, and what we are taking is student liquid ammonia NH3. So student, what will happen, one hydrogen from here, another hydrogen here. So dear student, what the product is forming student, CH3, this is C, this is double bond student, this is C, this is the CH3 student, here is the hydrogen dear friend, this is the hydrogen. So this compound is what student, trans, what is there student, butene, trans butene. So this is our required student, trans butene. So both are the different one student. Sodium in liquid ammonia you need to take student, hydrogen is there, and here is sodium also we have to take in liquid ammonia. So this one will prepare propene thus obtained. So the geometrical isomerism thing for this region to support your answer. So the if you are talking about the propane will also form the cis and trans alkene. Thank you students.